Okay, this is functions trig practice test for chapter 3. Your actual test is going to be just another version of this test. This is version A1. There's 4 other versions, so we'll pick one of those for a test. Okay, let's take a look at this one right here. It wants us to sketch the graph and include all necessary characteristics. Okay, well, let's take a look. This actually is a throwback to what we did in chapter 2. That's a quadratic. There's our parent function. What's happening to our parent function? Well, I have a horizontal shift, a vertical stretch, a reflection across the x-axis, and a vertical shift of +1. All right, now we need to do these in proper order, and remember what we learned. We need to do the horizontal shift first. So I've subtracted 4 from all the x values. Then next is the vertical stretch of 3, and I also, to kill 2 birds with 1 stone, I also put the negative in front of there, so I did the vertical stretch and the reflection across the x-axis. So what does that mean? I multiply all my y values by -3. The last thing I do is I take care of this vertical shift by adding 1 to all my y values. Here's my new t-table. I plot what are all my necessary characteristics. Well, for a quadratic, I need to have my vertex. I need to show that it has this axis of symmetry, and that's properly drawn. Okay, now here it says find the coordinates of the minimum or a maximum point. Again, I have a quadratic, my parent function. Now, what I know here, or what's important to me, is not that it's quadratic, but that it is a even function. Right? It is an even ordered function. Okay, so what does that mean? Then that means that the end behavior is either going to be both pointed up or both pointed down. This negative tells me that they are both going to be pointed down. So we have 4 scenarios of end behavior that we studied. I know it's this because of my even exponent. My highest order of this function is even, and this negative lead coefficient. Okay, so we call this the lead coefficient test for end behavior. All right, so that means my parabola is going to be kind of a frowny face, which means that the top point is going to be a maximum. All right, the maximum is going to happen at the vertex. The x-coordinate for the vertex is -b over 2a. We plug in the proper values. Reduce the x-coordinate of the maximum is 1/2. I take 1/2, plug it into the original function, and I get my output y value. So there's the coordinates of the vertex. All right, so if I go in at my graph at x, I will read a y value of 1/2, and that's as high as this graph is going to go. Okay, we're going to use this kind of in the next one. It is really no different than the previous exercise, except that it's a word problem, the dreaded word problem. Well, what do I have here? I have a quadratic. Okay, instead of x and y, y value is the height of an arrow, and the y value is the height of the arrow. The x value is the time after it has been shot. All right, but what am I going to get? I'm going to get a frowny face quadratic, an even ordered, a negative lead coefficient. All right, so this quadratic is going to have a maximum. All right, so if I was to actually plot this quadratic, height versus time, I would get some sort of frowny face parabola. Okay, so to find the maximum, I need to find the vertex. Again, -b over 2a reduces to 4. That's my x-coordinate of my vertex. Plug that into the original equation, and I get 256. So this vertex happens at x equal 4 seconds. And how high does it go? It goes 256 meters 4 seconds after it was shot. All right, so really all we are is a quadratic, and we're finding its max. Okay, this problem here, long division. The way that this is set up, we have to use long division on this problem. It does not have the characteristics that we need to use synthetic division. Okay, so I have the problem worked out here, and I showed all of my steps. Now, we have another video on Edmodo that shows all of our class notes for long division. Basically, it's your setup, placeholders if you like. Some folks like to use placeholders in the divisor. I don't. I always use placeholders in the dividend. That helps me. Okay, so what do I need? I need this first term, this first term. There's my division step. Okay, the result of my division step, it's x squared, so I put it in the x squared column of my long division. I use that number and I distribute it across the divisor, and I get this. Now I know I'm going to subtract that from my polynomial. So to facilitate that, I change the signs and combine. That avoids a lot of errors in sign mistakes. Yes, it's a subtraction, but I'm taking the opposite values and I'm combining it. It's add the opposite, same thing as subtraction. Okay, so I get this. I bring down this 10x, okay, and I'm ready to do a division again. What am I concerned about? This and this. And that, repeat my division step. I get an x. That goes in my result here. Take that x, again, distribute it across the divisor here. And then my subtraction step, add the opposite, bring down the 24th, repeat. Okay, and there's the rest of our steps. Again, if you're not a guru at long division, you need to get so. All right, our textbook and a previous Edmodo video outlines how to do long division. I have a remainder. This is the proper way to report the answer. All right, more on the next video.